I'm good. How about yourself?
I'm good.
Yeah.
Yeah.
Okay. So, um, the lesson I have for today is on electron configuration. So we're just gonna like thoroughly go over everything and every concept because I think I kind
Okay.
of just briefly went over everything last time, and I want to make sure that step by step you get it. Okay.
Okay.
That's what I have for today. I know that you said that you have homework that you were given Monday, and I know you have
Yeah.
exams tomorrow. Um,
Um, my chemistry teacher, okay, so basically my school was flooded because of how much rain there was on Monday. So actually we didn't have school on Monday. So my teacher moved my exam to next, which is really nice. And then she didn't give us any homework, which she usually does, but I think if we just go over like practice problems and examples, I think I'll understand
okay,
more
so
when
um, so okay, so the topic that I got from you was the electron configuration thing, right?
yeah.
Is
Mhm.
there anything else?
No, it's just that.
So you're gonna get tested on electron configuration.
Yeah.
Awesome. You're gonna be ready for that test.
Okay.
Okay. All right, so let's do this. Electron configuration. You know, apologies in advance if you hear stuff in the background.
No worries.
Let me see if I can do pen color. Right, you can see this, right? Okay. All right, so we're gonna go step by step when we're learning about electron configuration. Okay, we're gonna go by locating electrons first, right? And in order to do that, when you're locating electrons, um, we will go through four different levels, four different steps, right? The first level is the energy level, which is this one. And then and that's indicated by the row, and I'll show you that of the periodic table. And then within those energy levels, you have sub levels, which are what we talked about kind of last time, right? You have the S levels, the S sub level, the P sub level, the D, and the F sub levels, right? Right. And within those sub levels are your orbitals, and the types of sub level dictate the number of orbital. We said that, right?
Yeah.
Right.
Right.
Um, an example of that is, the S level has one orbital, right?
Mhm.
And then that is where the electrons are located within that orbital. We talked about that,
Right.
right? And each orbital is going to have up to at least two electrons.
Mhm.
Okay.
Okay.
So we saw this when we talked about it. I mean, I'm sure you guys talked about the Bohr model before, right?
Yeah, I think.
Um, and here you can just see like the different energy level where electrons are located. The number of energy level is indicated by the row down the periodic table. We talked about that, meaning like this is 1, 2, 3, 4, 5, and these are all the different energy levels, right?
Right.
7. And then the Bohr model, for example, in this case, aluminum, which is this one, kind of
Mhm.
tells us, shows that there are 3 energy levels for aluminum, right? Because you can
Mhm.
see this 1, this 2, and these 3, right? That shows you that there's 3 energy level, and this element is on the 3rd row down on the periodic table. Does that make sense? How the periodic table relates to the Bohr model,
Yeah.
right? And that just
Yeah.
really, corresponds to the number of electrons, right? The number of valence, because you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So if you had to do this for with a silicon, you would just add one more here,
Okay.
right?
Mm.
But that just because you have, I think the main point here is that there's three orbitals, three energy level where you will find the electrons. So I'm saying if you were to kind of surpass this for 5, 6, 7, 8, right? Because that's how much it holds, right? Then you'll have the next energy level, right? Right. And that would be like what? Because that would be 13, 14, 15, 16, 17. That would be chlorine.
Oh. Wait, so the amount of the circles are the orbitals, or wait.
Wait, let's see. Wait, this is, what is it? 12, 13, 14, 15. No, it was 13, 14, 15, 16, 17, 18. 18. Yes. Okay.
So the circles dictate the amount of like where the element is going to be.
Exactly. But the noble gases are kind of like an exception, because once you hit that fourth level, like you have the noble gases is just going to have all of the valence electrons completed, because you need 8, right? For one
Mhm.
energy level for it to hold 8. So the minute you surpass that, right? For example, 19, because now we're at 18. So the next orbital would have 19 electrons at the fourth level, which means that that's potassium. So that's how the Bohr model relates to the periodic table. Does that make sense?
Yeah, it does.
Okay. All right. So now let's just say, so within those energy levels, right, you have sub levels, right? And those are what we've been saying, SPDF. And these sub levels are where the orbitals are located, right? Within these sub levels, you have those orbitals, right? The orbitals are located, and those orbitals are where
Mhm.
the electrons live, right? So the
Okay.
sub levels hold orbitals, and orbitals hold electrons, right? Because S has 1, P has 3, right? D has 5 orbitals, right?
Mhm.
And then F has 7 orbitals, right? 7 orbitals, right? And so basically, and then another thing that's really cool about this is if you the number of its orbitals, and the for each sublevels, you should be aware of the shape of each orbitals, right? And the number of its orbitals and the number of its electrons. So this S sublevel is going to be your spherical shape, right? Which has 1 orbital. We said that 1 orbital, but that orbital will hold 2 electrons.
Okay.
Does that make sense?
I have a question.
Okay.
What's the part where it's like, is it the amount of orbitals can only hold 2 electrons? Or you said something about like something only holding 2. What
Yeah.
was that again?
Yes. So for example, right, we were doing like the S level only has like 1 specific orbital, right? this is
Mhm.
gonna hold 2, right? That specific orbital is gonna hold 2 electrons, right? We're gonna talk about the spins, right? And then p orbitals, this is the p orbital, has 3, but each of these
Uh,
are gonna hold on to 2 electrons.
I got it. Okay.
Okay,
So the um okay, so the arrows are the electrons,
right.
right?
Yes,
And the
and
orbitals are like the, I guess, dashes, but that hold the electrons, or
exactly.
like
So
below.
it's like, for example, your sublevels are like your house,
Mhm.
right? Inside that house, I don't know, you have like um different Tupperwares maybe. And in those Tupperware, you have to put things inside.
All right.
So it's like one Tupperware would equal to like, you have to put in 2 electrons on there. Maybe like 2 chickens. I don't know. You put 2 chicken in a Tupperware. So it's like, this is the S block is where I live. And inside the S block, I have orbitals. And inside of those orbitals, I have electrons in it.
Okay.
Does that
Okay.
make sense?
Yeah.
And the really cool
And
thing about this too is that what I want you to kind of see is that the number of electrons is 2
mhm.
times the number of orbital.
Oh, that's so cool. I didn't realize that.
Yeah.
So goes the number of orbitals, which are the dashes, or like the grouping, I guess you
Yeah.
can call it.
Yes.
So S is one dash,
Mhm.
P is 3 dashes, D is 5 dashes, and then F is 7 dashes, right?
Right.
Okay. And then the number of electrons are the amount of arrows like going up and down.
Exactly. So you can literally multiply the orbitals by 2 and you get all the electrons.
Right, because it's clicking because
Yeah.
like you said, like it's just doubles, meaning that the arrows always have to be like there always has to change because it's double. I don't know. That's not making any sense, but it clicks in my head.
Yeah. But like there's always 2 because that's like, remember the different rules that we talked about?
Yeah.
Like the off boss rule, Hund's rule, the level of increasing energy, and then Hund's rule saying that it has to you have to fill in one orbital first before you double up. You know what I
Right.
mean? So technically what I'm doing here is wrong. You should always go fill everything else and then double up first. But
Okay.
I think the gist of the idea here is just making sure that you make it easier for yourself by saying, I know the number of if I know the number of orbitals, I can
Mhm.
multiply that by 2 and figure out how many electrons I have.
Okay.
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 Okay. So now this is kind of like to simplify it for you. I know that in your actual periodic table, helium is on the right side, right? Usually, right? And we only put helium on the right side because it has a noble gas property. It acts like a noble gas, but it's still considered part of the s orbital. So in this picture, you're looking at something in which we kind of modified it a little bit. Even if when you
Right.
do the test and you look at the periodic table and you just like completely X out helium there and just like draw one next to it and like this is helium, so that it's easier for you to follow like where is which, so you don't get confused.
Mine is color coded. Like there's like a helium. There, oh, that's hydrogen, and then it's
Right. So
helium
the
on
helium
top.
is on the right side, right? You can literally like, if I know that you're gonna get like a blank periodic table on your test, right? And usually when I took chemistry before, whenever I get a blank periodic table, I already had something in mind on how I was going to arrange my periodic table. One of them was, you know, Xing out helium and putting it on the left side. And then another one was trying to figure out how to divide my metals, my metalloids, and non-metals. And this is probably something you guys haven't gone over, but like, this is one of the things that I did. I would separate my metalloids with my non-metals. I knew these were my non-metals. I knew that these were my metalloids, and I knew that these were my metals. And then in addition to that, I would also label all my blocks D, F, and P.
Yeah.
So that
Okay.
whatever I get questions, I can just follow my periodic table and not have to think about it and just answer the questions.
Yeah. So it's easier to follow for yourself.
Exactly. So my point here is just to let you know that, like, for example, your sub levels, your SPDF, I want you to see that the reason why, for example, this the p orbital holds 6 electrons is because there's 6 element across, right?
Oh. Oh, and then the S sub level is 2
There's
because
2
there's 2
across.
across.
And then your F level has 14 elements, and your D level has 10 elements.
Oh, I get it. Okay.
Okay. So
Yeah.
again, when you're thinking about this stuff, if you know the number of orbitals, you know the number of electrons. If you know the number of electrons, you know what sublevels you're in.
No, don't
right?
Mhm.
Does that make sense? Okay. Now, I know you asked about this last week, so we're gonna talk about it, right? So this slide is just showing you the different types of orbitals that are present within sublevels, right? Your S, your P, your D, your F, right? And if you recall, that the S sublevel had one orbital, right? One dash, and had and here that's showing you this is our S orbital, and this is in the shape of a sphere, right? And that is going to represent your S level. And your P sublevel has 3 orbitals, right?
Mhm.
And that's going to be your barbell shaped orbitals, right?
Mhm.
And if you kind of like, think about this a little bit, your orbitals here are in 3D shape because they each one of these orbitals are going to fall along the x-axis, the z-axis, and the y-axis. If you look at it, there's like,
Oh, yeah, I see.
it's crossing that one is the z-axis, and this is crossing your y-axis. So you can see that this is in 3D, right?
Mhm.
And each of these are going to hold your 2 electrons, right? And then as you go down your orbitals, it becomes a little bit harder to kind of explain what shape the orbitals are, but just understanding that your sublevel is at D and that level has 5 orbitals, especially if you have 10 electrons, if you have 10 elements, right?
I'm so sorry. You're like cutting out just a bit. Can you repeat the last part?
Oh, the last
It
part.
might be my internet. I'm so sorry.
So this is your D orbital and this is your F orbital, right? And that's going to have 5 orbitals, right? And each of those orbitals is going to hold 2 electrons, right?
Mhm.
But as you go down, like I was saying, sure, like in the S level, you can describe that as a sphere. And then in your P level, you can describe that as a dumbbell shape. But as you go down, it becomes a lot more difficult to describe what shape it is. So usually we're not really even going to describe what those shapes are. Sometimes some teachers will ask you to describe them, but that would be really mean. That's not really the goal there. The goal is for you to understand how much orbitals there are and how much electrons and that are going to be present,
Okay.
right? So, just remember that these orbitals are located within the sublevels, right? You have to have an address in order to find the sublevels, and the sublevels are the addresses,
Okay.
right? And within the
Okay.
energy levels, these are the space you will find your electrons, right? You will find
Uh,
electrons inside of, okay. Now, these,
I get. Okay.
so now these electrons are located within the orbitals. I said that already, right? And each electrons have the opposite spin. This is kind of how when we do draw those dashes, this is what that means, right? We call it a spin. Each orbital holds up 2 electrons. They must have an opposite spin. That is another rule that we talked about from last week, which was the off-buff principle, right? Meaning that it has to be an increasing energy level. Second, it has to fill in the energy level first and then double up. Now, this rule is telling you that they have to be an opposite spin, right? And one going up and one going down, because that means that they're spinning in 2 separate directions. One of them are spinning this way and the other is spinning that way,
Mm-hmm.
right?
So,
Because like
so this,
if you were imagining the Bohr model, right?
right.
Imagining the Bohr model, you don't you want this one to spin this way and you want the other one to spin the other way, because you imagine when you're thinking about electrons, you're thinking about like these charges, right? And if they get close to each other, they can repel each other, they can cause tension. So they spin in separate directions because they're trying to accommodate that.
Okay. Okay. So the spin is the direction that they're going to be in, and they're always in opposite spin. And then the electrons are the arrows again,
Yeah.
right? And then the orbitals are like the
Live in. Like
sorry.
the orbitals are where they live in, right?
Yeah.
These circles, the Bohr
So
model, these are the orbitals.
when we're drawing the configuration, the orbitals would be like lines on the bottom, right?
Right.
Okay.
Okay. So now let's go to the next one. So now this is just kind of like breaking down. I know that you've learned this. We talked about this last time, and this is just, letting you know what, kind of just breaking it down a little bit, a lot more. Number 1 is your energy level 1, which is where helium and hydrogen is. S is your sublevel, and 2 is your whatever element it is, right? In this case, that would be helium, right? And what's S2, right? So now I'm just gonna do a couple of practice, right? This is just
Okay.
and then if you just notice something here, because this is, we move helium here, so these are your different like energy levels, right? And then I also just want you to notice, because I know last week we talked about this, right? You have to put the D level. You have to start it by number, the 3D, 4D, 5D,
Yeah.
6D, right?
Listen, what confuses me is I think I understand it now, but what confused me before was how all of them like go in like 1, 2, 3, 4, 5, but then when you get to the D, it like is one by
Yeah.
behind or something.
And
Yeah, it's
then,
one behind.
so this is D level is one behind. And then another thing that I need you to notice is that the um, orbital is two behind.
It's two behind.
Because now this
Okay.
is, because now you go from like 3, 4, 5, 6, and then 4, right? Because you started at 3 here, which was like one behind because it's supposed to be 4. Now here it's supposed to be something else, but it starts at 4 instead of, you know, 2 or something, or 3, right?
Okay. Okay, so where does S end? Like what number at the end does it end in? 7?
SN.
One, two, I think it's 7, right? And then F would start at 5 on the
Yes.
bottom.
Yeah.
Okay.
What I want you to notice here is, look at this. It's kind of cool. You have 56, right? 57, and then it goes to 58, 59, 71, right? 79, 71, 72, 3, 4,
That's so
8,
weird.
and then 80.
I don't
And
like that. I would,
exactly, like that was really confusing the way they did
yeah,
that,
I
but
don't
like,
know. Whoever thought of that, like did that, because that's like, I don't know. It's way more confusing.
yeah, so that's
But
why these sub levels are important, because that's
mhm.
and knowing that, the last two is 4F and 5F, and it's mainly probably because the way that the periodic table is arranged that way.
Okay.
Does that make sense?
Yeah. Yeah. Yeah.
Okay, so
D is one behind, F is 2 behind
right,
S and P. Okay.
just know D block starts at 3 and F block starts at 4.
Okay.
Right. Okay, so now um I'd like for you to generate the configuration for sodium.
Okay. Do you want me to do the arrow or like the number part? I don't know if that makes any sense.
Just the entire configuration. We'll do the short version. I'm gonna talk about the short version in a little bit as well.
All right. So NA. So it would be sorry. You would start at hydrogen. So that would be 1s.
Mhm.
Sorry. Would I know in math we like do like the number on the top. Do you want me to do that too? Like
Yes.
1s2? Okay, 1s2. Okay. And then helium is 2s2.
This is helium, right
Or
here.
not,
Yes.
that's sorry. So it'd just be 2s2.
Mhm.
And then it would be uh 3 would it be 3s 3s
Gotta go by increasing
2,
energy levels, right?
yeah.
You can't
Oh,
skip.
that, I'm sorry. It would be um 2p 2p 4 or 2p 2, or what's the p, what's the I'm just confused about the number on the top. Like, how do you determine that?
Okay, so I'm gonna walk you through this one and then you'll do the next one, okay? So here's
Okay.
the deal. When you're thinking about figuring out the electron configuration, right? You start off with I said earlier, the number of elements across tells you the number of, also helps you figure out the number of electrons, right? Or the number, yeah, the number of electrons that that orbital will hold, right? So we said earlier that S level holds 2 electrons, and the P level holds 6 electrons, and the D level holds 10 electrons, and the F level holds 14 electrons.
So that
Right.
would determine what's on the top, right?
Yes, this is going to determine the number of
Okay.
electrons is going to determine what's on the top. So this is 1s2 because you have this, you would consider 1, 2. Those are 2 different electrons, right?
Okay.
So 1s1 would be hydrogen, 1s2 would be helium.
I understand. I think I can finish it probably.
Okay.
I was just really confused for a second. Okay, so we did those two, 1s2, 2s2, 2p, 2p, 2p6
Yeah.
because it's okay, 2p6. And then because sodium is right there,
Mhm.
would it be 3s? Would it just be 3s2 or like the actual number like 3s11 or
The number, there's always, it's going to be 1 electron here, 1 here. So that would be 3s1.
3s? Wait, can you explain that part one more time? I'm so sorry. I just don't really get like oh wait, I do. I'm sorry. Because it's like the place where it's at. So say we were trying to find magnesium, would it be 3s2 because it's like in the second place?
Yes. And
Okay.
this just the reason why this is 3s1, let me just explain this. Because this is the Bohr model, right?
Mhm.
We know we said the first level will hold 2 electrons, right? Then second, we said 1, 2, 3, 4. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then our third orbital is going to have 1 more electron right here. That's going to represent the 1 electron that is going to be here.
Okay. I have a quick question, sorry.
Okay, go ahead.
So say we're trying to find the element in D, so something in the middle. So can I just pick a random one? Can I pick let's see, can I pick iron in the middle? So I would count
Iron
from
is,
scandium all the way to iron, right? So it'd be 1, 2, 3, 4, 5, 6. So it'd be like what's 4d6 for that, right?
it would be 3d6.
Oh, right. Sorry, I forgot it started at 3.
Right.
Okay. Yeah.
Yeah.
That makes a lot. Okay. So you just count like the places, like
Yeah.
for the last number, you just count the places it's at, right?
Yeah. So technically, if you want to make things easier, just each element will count for 1 electron. And that's because
Okay.
like 11 here, for example, sodium, there's 11 electrons, 11 valence electron. All of these have been stabilized. And then there's 1 more left on the third interval. And then if you add one more right here, that
Mhm.
will be considered magnesium, right?
Mhm.
But the only reason why it is magnesium is because you added one more. So every time there's one extra electrons, it becomes a whole different element.
I see. Okay.
Does that make
I
sense?
think, yeah, I think I can do the
So
second one. I'm kind of confused for
yeah,
that
so
one, but yeah.
technically just like, like I said, the p orbital is going to have 6, and that's because there's one, each of these are going to represent just one more electron that makes it a different element.
Right.
know
Okay.
2p1 is boron, 2p2 is carbon, 2p3 is nitrogen, 2p4 is oxygen, just because I get, there's just one more electron. And that applies for all of these, depending on what level, depending on what um, energy level they're in and
Okay.
sublevel they're in.
All right. I think I
Okay, so now, um, well, that gave you the answer. But, still, I mean, I know the answer is right here, but like, can you explain to me why this is the right answer?
Oh, sure. Okay. So you just went over everything. So sorry, it's hard. I'm like pointing that I was like
Boron is
pointing to it.
bromine
Um,
is right here.
okay. So 1, 2 would be hydrogen and helium, and it's because it's like it's the first place, and then S is and then it's on the I, and also and 2 equals the S block. So that would be the first part. And then 2s2 would be it would be the one below it because it's in the second spot, and it's in S side, and it's also would have 2 blocks. And then 2p6 would be on the other yeah, it would be on the other side,
Mhm.
um on the right on the right side, and then p equals 6,
Right.
6 o'clock. So yeah, that would be there. 3 would we would go back to the left side, and it's in the S area, and then S equals 2, so that would be crossed out. And then the next one is 3p6, and you would go back to the right, yeah, the right side, and the p equals 6, so that would be there. And then where are we? 3p6, and then you would be 4s2, you would go there, right? Okay, and then this is where you get into the D section.
Right.
So D starts with 3, so it would be 3, um, 3, sorry, 3d10, because D equals 10 block, right?
Mhm.
And then you would go into the P section,
Mhm.
but for P, you start from, what is that? Gallium. You start from gallium, and you count 1, 2, 3, 4, 5. So it would be 4p5 because it's in the P section, and it's like 5 spaces from gallium because that's where it started. So it'd
Right.
be 5.
Okay. That makes sense.
Yeah.
Okay, cool.
Okay.
All right. So now we're gonna go through something that we call the shortcut called noble gas configuration. A shortcut. And the reason why it's called noble gas is because literally you have to reference the last noble gas before you can figure out what is the actual, the shortcut for the configuration. All right, I'm gonna give an example. This is, you just explained to me how to do barium, right?
Mm-hmm.
So the step in order to get to the shortcut is that you have to figure out what was the last noble gas that I passed. In this case,
Noble gas are so sorry.
so in this case, you went through, this was your 1, 2, 3. These are your different energy levels. You passed the third energy level, and that last noble gas was argon, right? So if this is kind of like your, kind of like treasure hunting, like you put argon as the last spot, you kind of gave yourself a clue for, right? Argon. And then from there, you can start to derive as if you were going through the configuration again, right? For
Right.
example, you'll say argon and then 4s2, 3d10, 4p5, 4p5, right? So it is the last noble gas, 4s2, 3d10, and 4p5. That's how you get to your shortcut.
I have a question. Are the noble gases just the column on the very far right?
Yeah,
Like
all
the
of
last column? So
these are all
neon
noble gas.
to uh neon to I don't know if I'm saying it right. Radon
Neon to
or
yeah, whatever you that
okay.
exactly.
Um
Helium is not a part of it. So for example, if I were to ask you what's the shortcut to rubidium, you'd say
sorry,
KR.
what
Rubidium.
rubidium, where is that?
This one.
Um
So that would just be
oh, okay.
5s1.
I get it. So it's basically just the shortcut is on like before, like the one on the top before the number or before the element.
The last noble gas you passed.
Okay. So for example, um, francium, I don't know if I'm saying that right, sorry. Francium, the last noble gas would be radon.
Mm-hmm.
Okay, got it. And then can you explain one more time the numbers or the configuration that goes after it? Like, how do you determine that? Is it just the last, always just the last
Yeah, so
three?
like when you get yeah, so pretty much like whatever your last noble gas is,
Mhm.
the if it was krypton, then you will derive the electron configuration from there. So krypton would if we were trying to figure out what tin was, right? You would say, okay, to get to tin, I need to make sure that I reference to you, I give you a clue, make sure I give you
Right.
a clue like your KR, your krypton. But then from krypton, I'm like, okay, krypton to what is that? 5s2, right? 5s2, and for D10, and then 5p2.
Okay. So it would basically say we had the configuration. It's just the last three. I don't really know like the last three numbers, like the configuration plus the last noble gas.
I don't want to say it's the last three because you're not always gonna get the last three, because like if you had rubidium, that would be just the last one.
Oh, okay. Rubidium would be this one.
You know,
Oh, I get it.
I'm
It's
just
just right
saying, like, for
there.
example, if you were doing if you were doing the, barium here, BR, and you wrote out all of the configuration as if I just wanted you to write everything out. You started at 4s2 right here because you gave me a reference of argon, because everybody know in chemistry that if you get to argon, that means that you have done 1s1, 1s2, 2s2, 2p6, 3s2, and 3p6, because we know that argon is 3p6, right? So me saying argon just means that you don't need to write this whole thing out, because this represents a noble gas.
Oh, and then just the last.
And then
the
the last three. In this
All
case,
right.
the last three. But if you had, for example, I can write out sodium here. What is that? I'm sorry.
That's
Okay. So it's sodium here, right? I can write out sodium. And sodium, I would say you have 1s2. I think we had it earlier here. Or I would say 1s2, 2s2, 2p6, 2s2, 2p6, and then 3s2, right? Right.
Yeah.
So in order for me to give you the shortcut, I'm like, well, what was the last noble gas here? It was neon. So I have to say neon, right? Parentheses, and then just put 3s2 here, because neon still represents this 3p6 thing. This is the the 2p6, right? Because this is second row at the p orbital, which is 1, 2, 3, 4, 5, 6, right? This, if I asked you what the electron configuration was for neon, you're going to tell me 1s2, 2s2, 3p6, right? If I asked you the electron configuration for sodium, you'd say 1s2, 2s2, 2p6, 3s2. But if you want to give yourself some time, you're just like, okay, the noble gas is neon, 3s2.
Okay. So it's just the last part for neon because it's like.
Yeah. So for this one, obviously, is on, there's only like one more energy level and it's orbital. But if you were to be given, phosphorus, that means you would have had to put 3s2, 3p3.
Okay. Okay.
Makes sense?
Yeah.
But then if I was to give you arsenic, right?
I
Right?
would give, would it be 3?
It would
after?
be a different noble gas, right?
Would be AR, and it would be, I'm not quite sure what the last configuration would be. Would be
What would it be?
4s2,
Mm-hmm.
3d10, wait,
Mm-hmm.
10, and then which one are we doing? I'm so sorry.
Arsenic.
Arsenic is right there. So 1, 2, 3. It would be what is this? 4
Mm-hmm.
D 4P3.
Mm-hmm.
I get it.
Got it?
Mhm.
Okay. All right. So now I want you to do that for silver. I want you
Okay.
to write it out on your piece of paper.
Everything.
On your piece of paper. Just figure out what the full electron configuration and then also the short one. And then once you finish it,
Okay.
let me know. I will give you, let's see, I'll give you, let me, one second.
Gosh.
Let me time you. I'm gonna give you 5 minutes.
Oh my god. Oh my god.
I'm gonna give you 5
It
minutes.
stressed me out. Hold on.
I will give you 5 minutes to figure out the configuration for silver number 47. 1 second. I'll tell you when to go. 1 second.
I'm stressed.
The silver full configuration and the shortcut.
Okay.
Go.
Okay.
Wait 1 second. Sorry. 1 second. Okay. Now go.
Okay.
You have 3 minutes left.
Okay, I think I finished. I don't know if I did that right though.
Okay. So what I want you to do now is to type that in the chat.
Oh my god. Okay.
Or you can show me on your camera. I can barely see it.
Can I read it out? Do you
Okay.
have like the Okay.
Yeah, okay.
Okay. You have the answer, right?
Yes, I do.
Okay. I don't know if this is right. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 3d9, and then the shortcut version, I think, is KR5S2 3D10. 3D9, sorry, 3D9. I did it right. Oh my god, I'm so happy.
Congratulations. That's awesome. I'm happy for you.
Oh my god. I was like, I definitely have somewhere in there.
In 5 minutes. Oh, less than 5 minutes, actually.
That was really good.
Yes. Congrats. That's
Yay.
awesome. All right. So here's another last tricky one, okay? Because I think this is our last thing for today. Is when you have to figure out the shortcut for an actual noble gas.
Oh god, how do you do that?
So in order to find the configuration for the actual noble gas, you have to go back to the last noble gas.
So is it argon or argon?
Yes, it would be
It would
argon.
be argon, sorry, argon.
Yeah.
Would it be neon?
Yes, you'd have to put neon there, Ne, and then just derive the configuration from there, which would be what?
Which would be 3s. Wait, would it start? Wait, would it be 3s 2 and then 4s2? Like, would it start there?
Why would
From
it
here?
or S2?
Oh, I'm sorry. I'm literally so sorry. I'm being sorry. Ignore that I said that. I was looking at something else. It would be a 3p. 1, 2, 3, 4, 5, 6. 3p6.
Exactly.
Oh. Okay. Wait, so for like what's a different one? Rate or like radon. So it would be you would go from xenon.
Yeah. So just put like I'm looking for radon, right?
Okay.
And then you put XC in the parentheses.
XC. Okay,
Then
XC,
you
and then it would be 6
Mhm.
6s2 and then it would be 5d10
Mhm.
and then it would be 6p what's 6? I mean, but yeah, it'd be 6p6.
Right.
So sorry. Why? Oh, Jesus. Why is my phone like ringing so much?
Yeah. So that's like literally how you do.
Okay.
Okay. So here's what we're gonna do now, because I know you sent me something on my email. Um. Uh, that has your homework in it. So we're gonna look at that real quick. So I know our time is running out, but
Okay.
that was already an hour. Isn't that crazy?
Oh my gosh, that's insane. Okay.
Let's see. You sent me something, Sienna. When did you send that? That was okay.
We got black George hats.
Okay. So these was what you sent me, right?
Okay.
And
Okay.
I'm kind of confused on how you would figure out like the element based on the configuration.
so here you said the A, right?
Yeah.
A is so it's 5 o'clock, but we'll keep going.
I'm so sorry. You. It's
So So A is you have 1s2, 2s2, 2p6, 3s2, 3p2, right? And this is our
Mhm.
what should I call this? This is our this is our let me just this is our let's just say this is our periodic table, right? So it's kind of like the same thing. It's just doing it the opposite way. They're just telling you, what if I gave you all of this configuration? What element am I? You just have to follow that. And you can even just go from like whatever the last thing was, you'd be like, okay, this is silicon, right? Right here. So you know that in order to find silicon, that you know this is one energy level 1, 2, and 3. So you know that on the energy level 3, 3s2, 3p2 is your silicon.
Oh, because that's where it ends.
Yeah, it's just
How
that.
about for the shortcut version?
For the shortcut version, you
Or-
literally just like go to AR.
Oh, that's so easy. That's so much easier. Hold on. I got it.
Yeah.
Oh, okay.
So
So,
4s2
okay.
is calcium, yes.
Yeah, calcium. And then 3p2, 3. Oh my God, that's so you can basically just go to the last digit of the configuration to find the thing, right?
Exactly.
So like, okay, that's so easy. I was like literally like, I was like, how do you do that? Oh my gosh, it's gonna be so hard.
Yeah. So
Okay, I got it.
once you like, once you understand the concepts, it becomes easy to like answer these questions,
Okay.
right?
One more quick thing
Mhm.
for how many valence electron does each of the following have? How do you determine that? Oh
Um,
wait, yeah, I know. Maybe I don't. Never mind, I don't. How
okay.
would you determine? I thought I did first. I was like, I don't
I'll
know.
give you an example. We talked about it earlier. Remember this energy level here? This Bohr model?
Yeah.
And we said that this is at 3p, what is that? 3p, what is that? 3p1?
Mm-hmm.
Right? That valence electron is in that orbital. You see that orbital? It has 3 energy level.
Mm-hmm.
That 1, 2, 3 is the amount of valence you have left,
Okay.
right? So, for example, in order to find out the valence electron of something, you would do this, right? So this is aluminum. We'll just say, okay, this is the first energy level. That first energy level will house 2 electrons. 2, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8. And this is, every orbital has to reach an octet rule, which is 8, right? So now that is 8, 9, 10, 10, right? But this is in like number 13. That's element 13. 10, 11, 12, 13. This is not that this doesn't have 3. I mean, this doesn't have 8 electron in that orbital, right? So now you got to say that there's 3 valence electrons that is left in this third energy level. In this third orbital, there's 3 more valence electron that's left. And that's the same for like, if you were to put 39, I don't know why they gave you so much numbers like that, but I mean, I guess 39 is right here. But this is technically like,
Oh, it's just the last. I get it. So can you give me like a random element and then can I try to do it?
Yeah, so let's see if you had like magnesium. What's the valence of like
Magnesium. Okay, wait. Magnesium, wouldn't that just be 2? I don't know.
so magnesium
Is
has
it
12, right? 1,
it has
2,
12?
3, 4, 5, 6, 7, 8, 9, 10.
Oh wait. Oh wait.
There's 2 more. So the valence election is 2.
It's 2. I got
Yeah.
that right.
Mhm.
Yes. Okay. Um
And that's why your valence electron for aluminum is 3, your valence electron for silicon is 4, for phosphorus is 5, for this is 6, 7. So,
okay.
and that's why he's probably like, you can go anywhere in the periodic table, you can pick this and you'll still, 5, and then they'll start up.
1, 2, 3.
This one, what is this with?
That
30.
would be 3, right? The one you just saw. Like, I don't know how to pronounce it.
Yeah.
Yttrium would
Yeah.
be
So
3.
this would be 1, 2.
It would be. Oh, I think I marked it down. Oh yeah, it is supposed to be 3. I did 2. I think that's a mistake.
Okay. Yeah. So
Okay. Cool.
yeah.
That's the
So that's
last
basically how you do that. And then your test is when again? Next Thursday?
Monday. Monday, next Monday.
So not so this coming up Monday.
Yeah, this upcoming after Halloween.
Okay. But you're gonna get tested in all of this, right?
Yeah, I actually know how to do the arrow part, so I think I'm okay for that.
Sorry, what? Oh, this one, the error part, but like
Yeah,
everything else you're good with? This writing the general
I think
valence?
yeah, I think we covered that.
Okay.
Yeah.
As long as everything makes sense.
Yeah. Hopefully I do well on this one.
Yeah, I think you got the gist of just make sure you're reviewing.
Yeah.
I'll send you this PowerPoint. I'll send you this so that you can have it as like a reference to review.
Yeah, thank you so much. I think I'm just gonna go over my notes and everything else, and hopefully I'll just keep practicing doing everything.
Yeah, and if something comes up on your test that you took the test and you still got some things wrong, make sure you send me whatever that is, and then we can review that on whenever we meet again. Like, because I know we didn't really get the chance to review this last 2 blocks here. So if anything comes up like that, just let me know.
Okay. Thank you so much.
And yeah, so I'll just